Today we will go through analyzing data in text form. Some examples of text form include a research paper, or it could be tweets which people write on Twitter or comments on a Facebook. This is a general process that is involved. We start by reading a file. So we read a file and then build a corpus. Corpus is collection of documents. So when you read a file which is, let's say, a research paper, then the software will break it into different documents and then build what is called a corpus. That corpus is then cleaned. We clean the text, we remove things that we do not need in our analysis or summary. So we may need to remove punctuations or some website links and things like that. And then we create what is called term document matrix. So in the document you have so many words and how often each word appears. So we create a matrix for that and then we make a plot, something like a bar plot, and go back and forth between analysis and plots, and sometimes even go back to cleaning text and again creating a term document matrix till we arrive at something that we want.
Now I will open RStudio.
And then I will open the file which I have downloaded from the course website. So this is the file we are going to use. So the first line is library TM or text mining. So if you do not have this TM package, you'll have to install it. So if you click on packages in the fourth window, click on install and say TM. And then click install. You'll be able to install that package. So this is the first one. So since I already have it, so I'm not going to install it, since it is already there. So I will simply run this line and then the next line, which is the default option when you are dealing with text. So I don't get any errors, so everything is fine. The next line is set WD, which is set working directory. So this allows you to set a directory wherever you store your files, and that way you don't have to type the entire thing and again and again. So right now my data file or .txt file is in this directory. So I have stored that in R files directory on the desktop. And the file name is rai2009.txt. So if you are trying to read the file, make sure that you use a current directory. The correct directory, because this is for my file. You can see my name is here. So this will work only on my computer. For your computer, you need to find out where you are storing your file and then give that directory. So I'm going to run this. And then the next line will read lines from this particular file, .txt file, and store everything in text, text. So this is a name given by me. You can call it my text or any other name. So I will simply run this line. You might see a warning message. So warning message is generally fine in R. As long as you don't get an error message, you are fine. So this is okay. And then in the next line, we convert this text file into a corpus. So after reading the file, we are building a corpus just by running that one line. So again, this name is given by us. We can give it any name we want, but this is the function which is used for converting text file into corpus. So this is the name of the file, text, where our data is stored. So I'm going to run this line as well. So now I have created a corpus, a collection of documents. So if you are just curious to see what this text file is, so I'm going to simply type text and hit enter. So this is going to print everything from that file that we just read. So let me expand this. So you can see the first document contains name of the journal or research journal, IEEE transactions on reliability, its volume and year and so on. Another document, number 5, contains the title of the paper, research paper, warranty spent forecasting and so on. Sixth document contains name of the author, and then you have abstract and so on. So you can see this entire research paper has been read. So if you want to inspect the corpus for the 8th document, so you simply type in and click enter, and you will see it gives you only the abstract part. So now let's start with the cleanup. And the first line, what basically it does is it takes all the documents in the corpus and converts it into lowercase. So for example, in the abstract you see A is capital, this although A is capital and so on. So all those things will be converted into lowercase and stored in corpus again. So let's run this and we can inspect this again. So if I go up using upper arrow, I can bring this inspect function again, hit enter. Now if you look at abstract, you see this has become lowercase, A has become lowercase. So all the alphabets are in lowercase now. Now I'm going to remove punctuations using the second line. So run, and you can again inspect and see all these full stops will be gone. So now there are no punctuations. Similarly, next line, let me see if there are any numbers here. So in fact, there are no numbers in this one, but we can use probably number 465. You will see there are some numbers like 2009 and so on. So let me first run remove numbers line, and we'll go back to 465. Check. So 465. So in that line there are no numbers now. Similarly, you can also remove English stop words. So for example, in the abstract you have some very common words that appear, and in case you want to look at what are the stop words in English, so you can simply type stop words English and hit on enter. So these are commonly used words in English like I, me, my and so on. So all these will be removed from entire document. So I'm going to run this line and we can inspect number 8. So I'm using the upper arrow to bring this up. So you may notice that now the common words are removed. Actually, you may notice that still you will see the, it and so on. And that's happening because I ran inspect corpus, but after removing the stop words in English, we are actually storing the output in clean set. So I should have used clean set. So let me type again. I would say inspect clean set and then number 8. So there you will see those common English words are gone. But wherever those words are removed, you will notice that there is some white space left. So that's what next line is going to clean. It will strip white spaces from the entire document. So you'll see that those white spaces are now removed. You can also run these ones if you have TM package which is 0.6.0, then we need to run this. And then we can create what is called DTM or term document matrix. So I'll run this. So now we have converted the original file, we have converted them into a collection of documents, we cleaned the text, and then we have converted into term document matrix. So now we have several words, and we can also see what are the most common words or most frequent words. So for example, this one says find frequent terms in whatever we stored in DTM, that term document matrix, and low frequency is 2. So let's run this. So this will print all the common words that it sees. If you say, let's say low frequency 20, so please remember we got like 421 rows. Now if we say 20 instead of 2, we'll get fewer because it will only report those terms which occur more than 20 times. So I'll go back to 2 and go to the next line. So now we can create a plot. This can be done by running term frequency. So row sum means for each term it will find out how often that term appears. And because that may give rise to too many bars, because we may have too many words, so we can cut down by specifying that we want only those terms which appear 10 times or more. So I'm going to run this. We need another library ggplot2. So if you have not installed, make sure that you install that package. So I'm going to run it because I already have it. So you may see some messages from time to time, so you don't need to worry because there's no error. So everything is fine. And then bar plot. So this is the plot we get. It's very busy. It has too many words. So in fact we can go back, and if you want you can say I want maybe only those terms that appear 15 times or more. So that will reduce some clutter. So you see now we have fewer bars. Now one thing you might see in the bar plot, for example, there could be some words that you do not want. Note that they are in ascending order, like alphabetically. So you have B, then C, then D, and so on. So there is a bar against FIG, which are figures or the pictures in the research document. So obviously we don't need that, and there could be some words that we don't need. You can remove the words using this command. So tm underscore map and we are using now clean set. And if you look at the command, it says remove words. So remove, W is capital, remove words, and then within C you can say FIG, then comma, again colon, and we also want to remove PER. So if I run this, I made a mistake in the spelling. So clean, so there should be N. So now it runs, and I remove the white spaces. I have to run this line, then convert this into term document matrix. Now you can inspect the words and you will see FIG is out, and similarly so FIG, so we don't see that, so it has gone out. And if you plot bar plot again, we'll be able to see that FIG is not there. Similarly PER, MNOP, so they are out. And you can choose any other word that you want to take out from your analysis. You can also replace some words. For example, we are talking about this research which is about warranty claim. So if a word claim and claims appear many times, you can replace them using this function. So I'm going to type this. So I'm going back and I'll type this in the next line. So clean set tm underscore map clean set, and let's look at the command. So g sub and then the pattern. So we want to replace claims with claim. So you should not do the other way. Like if you put claim here and claims here, that will mess up the things, because wherever it, even like within the claims, you already have a word claim. So it will mess up the things. So make sure that you replace claims with claim, not claim with claims. So pattern equals claims equals claim. So you will notice that you have claim here and claims. So these two bars will be added together into one single bar. So I'm going to run this and remove white spaces, run all this till we reach the bar plot. So this is our new bar plot, and you will see that there are no claims bar here, only claim. And whatever number we had for claims is now added, and that's why you see this bar is looking bigger. So suppose we are fine with whatever words appear in the bar plot now, and we are ready to make a word cloud. So in that case, you move to the next block, and you would need a library word cloud. So again, if you don't have it, go to packages and install, and type word cloud and then install it. Since I already have it, so I'm going to run this anyway. And I'll also run the next line. We are converting this document term matrix into matrix, and we are storing that in M. So I will run this. I will run this line. Now the set.seed is to make the graphs reproducible. So I have just put 375. So if I do it 10 times, I will get same graph. You could have any other number like maybe 555 or 123 or 1234. So I'll just use whatever we have. And then the next line. Now the first word cloud that we are going to plot is with grayscale. So if you want like black and white, if you run this, you'll get a black and white plot. So this is the word cloud. So this is what we have in this picture. So it will try to plot almost everything, all the unique words. And the first word cloud that you get may not be the perfect one. So we need to make some adjustment till we get what we need. So obviously you have too many words here. You can remove the clutter by specifying max.words 100. So in this word cloud you have only 100 words. I'm going to type somewhere here max.words. Let me see, is it word or words? So words. So S equals 100 and I put a comma. So I'm inserting it in this grayscale word cloud and I'm going to rerun this line. And now you can see it has less number of words, in fact 100 words. So less clutter. You can also use something called minimum.frequency to specify what is the minimum frequency you want in your word cloud. So for example, in this line we had minimum frequency of 5. So any word that appears like 5 times or more will be included. If I say maybe 10 and rerun, so you'll see less words will appear. You can also use color. So right now in this line, for colors I'm using gray levels. But if I say colors equals rainbow 20, then it will convert your word cloud into a colored word cloud. So let me insert max dot words that we already had in the previous line. So I'm going to run this and get a colorful word cloud. You can also have another type of color. It's called brewer.pl within brackets 6 dark 2. 6 comma dark 2. So that is another type of color scheme. So if we run this, you see different type of color. On the next slide you see how to vary the scaling. So each word has a different size and you can choose like what size is ideal or what size you want by using scale command. So I'm going to insert scale. So after running this, you'll see you have different scale. You can also change it like this 7 here is the upper limit for the scale. So that's the maximum size and 0.1 is the lower one. So the once you see like smaller words, they have minimum 0.1. If you think that's too small, you can increase it to maybe 0.3 and rerun your word cloud. If you think this upper limit 7 is maybe too big, you can say I want 6 and rerun. So you can always play with the scale by choosing a lower limit and upper limit. Similarly, you could also specify a percentage for the rotation of the words. So if you want 20% of the words to be rotated, like 90 degrees, you can use ROT for rotation, .per for percentage. So you can add it anywhere. So I would put somewhere here ROT.per equals 0.2 for 20%. So 20% of the words will be rotated. Remember, we have about 100 words, so that's the limit. So 20% will be rotated. If you think you want to rotate more, maybe 30%, you can say 0.3 and rerun that line. Now you see more words are rotated 90 degrees.